So we are entering the last phase of the project, and we're very excited that you guys are moving now into some technology development that follows up on some of your good schematic technology innovations. We are really interested to see how those technology ideas begin to come into fruition structurally, constructionally, materially, etc., and how they begin to sort of work with each other in the resolution of the scheme. So I want to talk to you a little bit today just about the focus area. What do we mean by the focus area? And then maybe a little bit about wall sections, but mostly about the floor pack. This is the kind of mystery zone of architecture where we will talk about the floor-to-floor area and then refer to this sort of space which is typically not drawn in, but in an integrated project it is drawn in. So it's that sort of space between the space we occupy below and the floor and construction up above. So oftentimes that's in a plenum, but sometimes that's out in the open. And so we're interested in having you explore, both articulate what's in that floor pack area, but then also consider the degree to which that helps you with the expression of the project. So I want to refer you to a really wonderful site, Diversare, which is probably not how it's pronounced, but it's an Italian site that has really quite extraordinary repository of drawings, and they are some, kind of your more schematic architectural drawings or some more detailed architectural drawings, but they do have a very lovely set of construction facade details where you can really start to see on some exceptionally beautiful designs how the facade is kind of conceptualized and planned for construction. So you'll recall this focus area in the past has been an area that students will select from their project, kind of an area of emphasis in the project, something that is sort of close to their hearts, and maybe the most interesting areas technologically, or an area which has quite a bit of technological integration. And we have in the past made physical models, and absent the access to the shop this year, we are going to have you develop this area just as a digital model. You can see that really this is covering a kind of serious connection joint. This is covering a major space. So you will need to decide on that area for your particular project. And again, we are kind of collapsing this without being able to build the models. We are collapsing this with the wall section. So when you think about the kind of components that would be in your typical wall section, we're asking you to combine that with a 3D view. So I would recommend some kind of an isometric view where we can see both the construction as it's cut through, as well as the elevations. What are we actually seeing and experiencing from the exterior as a result of this construction condition? And I want to thank Perkins and Will for this beautiful section, which sort of fits the bill pretty perfectly. And I really like it in a lot of ways. We've got a lot of different material systems that are coming into play, but we also have a lot of miscellaneous materials, miscellaneous metals, which help to construct some of these shapes and figures that are part of the profile of the building, but will be a part that is kind of hidden from view. But you can see a truss condition here built up of standard steel sections that is doing the spanning and allowing this large wall to be relatively unencumbered. But we also have concrete details, so combination of concrete and steel. And this kind of a drawing should show all of these components of the wall section, the structural frame, the columns, for the vertical loads, or if you have something other than columns, for example, load-bearing walls or shear walls, but also all of the horizontal components, so girders, beams, and joists, the hierarchy set of strongest to medium to lightest, which can come in solid members like wide flanges, but can also come in trussed members. We have truss girders, truss beams, and truss joists as well. We also want to see your attempts to deal with bracing, lateral bracing for the building. So that needs to happen in the X, Y, and Z axes. And in this axon, we would begin to see that as probably a spatial device. And then miscellaneous metals. I actually really love miscellaneous metals because I think when we have a vision of a profile the way that that profile comes into being oftentimes requires a lot of miscellaneous steel that will never be seen. So we've got this significant truss, but we also have these sort of cantilevering shelf-like brackets that are holding up both the underside panels as well as the top side panels. And miscellaneous metals are a huge part of the wall section. For the floors and roofs, obviously we would want to see the components of the construction at the different scales. If you are working in concrete, you're going to have different kinds of concrete structures as well as concrete slabs. But if you are working in steel, you're very likely to have what's called a composite deck. This is the one that you've probably drawn the most often in your wall section life. It's the corrugated metal decking with the concrete cast on top with some connector steel studs that allow them to act as a composite section. But a lot of you are working with CLT. One of the benefits of CLT, depending on the base spacing, one of the advantages is that we can go with a non-hierarchical system. In other words, we can go straight from the columns directly to a decking system and have a kind of flat ceiling condition with these CLT panels. So those would be conditions we would want to see at the floor and roof. And they're going to be more complex at the roof. Obviously, when we look in here at the floor, we don't have roofing, we don't have insulation. And in this case, we've got more of a utility space below. But up above, we're going to start to see much more complex sections where we begin to have insulation, roofing materials, etc. There can be a drainage, quite a few things can begin to sort of show up in that section. And then for the enclosure, we're going to want to see what kinds of materials you are planning for. So are those opaque? Are they transparent? And then what are the kinds of support devices that are necessary to support those systems? So in this kind of case, with a simple glass wall, we see something pretty familiar. It looks like a mullion. It probably is some kind of a mullion. But we see even the choices there are fairly important to the expression of the building. In this case, the mullion is sort of spanning toward the interior, leaving a very flush facade on the outside. And so even the choice about where the mullions sit within the wall, do they sit to the outside and create shadows? Do they sit to the inside and create a kind of flush surface? Is an important connection that we would want to see in the wall section. And the other thing that I think is really important at this scale of building is to really think about the overall support for that enclosure. I think in a lot of buildings at this scale, we will really see continuity of the enclosure element that slides right past the edges of the decking. So we might be thinking about a wall which sits on a floor and spans up to the next floor. But most often in this scale of building, we're really hanging devices off of the edge of the slab in order to carry those taller wall enclosure materials. So we're going to see quite a bit of that, and I'll try to point that out. So for the enclosure, frames and surfaces, what are those materials? But also thermal separations. This is one of the areas that you kind of have to track around the outside perimeter of your section and ask yourself whether or not you have a closed condition, thermal separations, and also insulation. We want insulation continuously. So we'll have insulation at the roof, insulation in the wall panels. Glass systems are built with insulation, but even under here we'll have insulation in this area in order to protect and sort of isolate some of these wall conditions. So really, this is kind of an important thing in practice. This kind of a drawing helps us to see the relationships between the parts, and I love this image of the camera. It's really beautiful how many parts are necessary to comprise a camera and that we can see them all kind of fitting nicely into each other. But in architecture, it really helps us as well to think about conflict resolution. Conflict resolution is basically where you have systems running into other systems, and we obviously have to avoid that. So if we were sort of imagining magically that the HVAC systems were running in the same space, and then they were suddenly confronting a piece of structure, that's a conflict. And so 3D imaging and 3D modeling is really a kind of way of negotiating conflict resolution, but it's also a way of really thinking about elegance of coordination. And depending on the kinds of constructions you are using and depending on your design aspirations, you may really be thinking about more of an exposed system, a system where we begin to sort of appreciate the different parts, we appreciate the technologies because they're in more exposed conditions. So it's both about conflict resolution as well as coordination. So I showed you this image on Monday, and this is not exactly a focus area, but I think it should help you to identify where your focus area is. You'll want to look for a key spatial condition, someplace in your project that thematically distills the ideas that you have. It's probably a public space. It definitely wants to be one of your larger volumes and a place where the technology is expressive. Otherwise, you will not have much to work with on the kind of technology integration drawings. But I also want you to see that it is not just a sort of decision about technology, but it's really a design decision. And I love this set of representations. I don't think this is a built project, but what I really like about it is that the thinking about the technology as a beautiful system, which has a spatial implication, is very evident in all of the drawings. And so I like this drawing quite a bit because we see this kind of layered condition of the skin around the kind of inner body of the building, which might be a condition that you're exploring if you're looking at sun shading devices. Oftentimes that sort of screen layer or shading layer is separated from the skin by some distance. And you would probably want to explore how that is supported, how that's held up. But I also like this because we have combinations of spaces that are really set aside for services. This is this part that we're going to call the floor pack. So this kind of area that in poche appears hollow, but in reality is full of all kinds of things. Ductwork, plumbing, electrical devices, everything kind of fits up in this floor pack. And so I really like here that they have identified zones where that floor pack is very active and very full, and then other zones where we have high degrees of openness. And it is not necessary, because these floor packs are doing sort of jobs on a kind of regular interval. It's not necessary to have these closed chambers everywhere. And we also see the use of the floor pack in shaping the space. So I like these moments where the decision is made for the underside of the ceiling not to be all on level. So where we sort of push the ceiling up and have a coffer and get the exposure of the structure is a very rich area, and it distinguishes this area from this area. So the floor pack, we can actually use them spatially too. They're not just a pragmatic zone, but they begin, depending on how we make them, to shape the space underneath. So I like this set of drawings for that reason. And then clearly I love this one where we have actually done a kind of exploded isometric and pulled a little bit of the skin out to examine it three-dimensionally. Each one of these has sort of lovely detailing and shows that layered set of relationships between the structure and the floor, the inner envelope, and then the outer set of shading devices, even up to the roof. So we want you to look into your project and really find an area that inspires you. Find an area of your project where you can capture quite a few things that are important, but you can also look at those technologically. How do they resolve themselves? How are they supported? How are they layered? And I think the wall section that we want you to pick is not an interior wall section, and you may have some very interesting wall sections on the interior, but we really want you to look at the exterior. This is the boundary and the barrier and the set of interventions between inside and outside that are shaping the thermal environment and the spatial environment all together. And so, this is kind of an ideal. This is what we'd like to see. We have the hidden area, and you may or may not have hidden areas. You may be more exposed, but we see the structure. We see its support of both in these large members and in these secondary members, its support of a decking material. We see below a suspended ceiling, which is kind of nicening up, making this space a little bit more predictable. But we even see down below a raised floor. A raised floor is a great way to run services. If you think about this, concrete composite decking is a pretty solid material. And so we may have issues running plumbing, running electrical. And this kind of a raised floor allows you to really run those systems up above the floor and to change things out, to be able to access those systems fairly easily. We see some thermal devices at the facade to keep the glass from building up condensation. We see some really quite beautiful sort of truss devices on the outside, which are holding these brackets, which are then holding the screens. So I think you want to think about what's the layering? What is the layering of my elements inspiring the construction? You might also think about other portions of the project that are related to your bioclimatic performance. So are you thinking about a stacked ventilation system? Or what is the shaping of the massing and how is that created with construction? Each of these we're starting to see into the construction. We're seeing an insulation layer, we're seeing a structural layer, we're seeing the material layers, and at times we're also seeing passive bioclimatic layers, or if we were in a hung ceiling, we'd probably also be seeing, like this, HVAC devices. So each of you has been doing a detailed HVAC drawing, looking at the kind of organization of the system, and now you will want to look a little bit at the details of the pieces that you've proposed. So do you have a ducted system? If you do, we should start to see the ducts in that focus area drawing, in that wall section drawing. And depending on your expressive ambitions, and if you're using CLT, oftentimes those are going to be exposed. I like this drawing because they're very beautiful ducts, right? We have some beautiful kind of registers and some beautiful ducts. And so if you're in a concrete system, you may be exposed. If you're in a steel system, at this scale, it's unlikely that you would be exposed, but you may have undergone some other sort of design changes to let that happen. But with CLT and concrete, we might make choices to expose these parts of the system. When we're looking at the section overall, we usually talk about the floor-to-floor distance. And the floor-to-floor is literally what it sounds like. From the floor above to the floor below, what are those dimensions? And maybe using technologies or even project types that have lower floor-to-floor dimensions and sometimes higher floor-to-floor dimensions. So just a couple of examples. I would expect lower floor-to-floor dimensions if I'm using a concrete frame. In some of those systems, we can collapse out basically this beam configuration. We can go straight from columns to slab, and so we get a reduced floor-to-floor. In a housing program, we also have the reduction of a lot of centralized ductwork. With our CLT slab systems, if you have your column spacing close enough, you can go straight to a slab even without a beam, which is kind of miraculous. And in cases where we have open systems, we may also expect slightly lower floor-to-floor. It's not always going to be this low, but I would say that's kind of your minimum, and we work up from there. 10 feet floor-to-floor is absolute minimum, probably only appropriate for a housing program. Our higher floor-to-floors are going to be in our public and commercial spaces if we're using a steel frame with a composite deck. So you see this stacked system necessitates that we have the structure, the composite deck, and then the HVAC systems below. So we start to build up quite a bit of depth here because the floor pack area is larger. So when we say 14 feet, that sounds extreme. But if we're talking about 3 feet of systems and materials, then we're really down to a much smaller space. So you are really thinking about what is necessary for this dimension, the dimension of the floor pack. So what's in the floor pack? Our materials, our structures, the frames, the bracing, the shear walls and bearing walls may sort of have implications up in the floor pack, but also our floor construction. And our mechanical systems, our ducts, diffusers, fans, and terminals, all up in this floor pack. As well as electrical, I didn't add plumbing, but light, power, telecommunications, but we may even have some plumbing configurations and systems in that area. So let's remind ourselves, thank you so much, David Thaddeus, for sharing with us that the beginning of this calculation starts with your structure, and you will want to think about the span ratio for your particular kind of construction. Are you using decking? Are you using open web joists? Are you using sort of special trusses? And I know a lot of you with longer spans may be using sort of trusses that span an entire floor. So we need to be reminded of these span ratios and also the degree of solidity. If I have a span ratio that requires a 10-foot deep truss, but I have a truss and I can continue to sort of move systems through these spaces, then I'm really not adding additional depth on top of that. But if I have a solid member like a wide flange or a plate girder and I cannot move my systems through that member, I need to use my span ratios and then add additional space for the HVAC systems. But then we also have to add the floors above. So what are we using to span? Are we using with CLTs a kind of built up slab, or more typically if you are building in steel, our kind of typical go-to is the composite floor with the steel decking and the built-up concrete. But if you think about having a 2-foot piece of structure and now 6 to 8 inches of this material, we're already almost up to that 3 feet that we need for our floor pack. So just to kind of show you some images of the floor pack and a few things that go on inside of there, as well as a few details. Here's a floor pack at the roof, and we're not really seeing the evidence of the material that is supporting the roof insulation. Probably it is running in the other direction, that the corrugations are kind of hidden from view, or they are very shallow, and that's quite a possibility. But you will see here, and I think what's important is that the insulation is sloped and allowing for basically the insulation and the roofing material to flow any rainwater, any kind of rain collected water into a drain system that moves through the roof to the floor pack and down into a drainage system. Also, I think important here, and what I like, is that there is a conscious attempt to think about the relationship of this dropped ceiling to the glass wall. So in this case, the dropped ceiling is held back from the wall, giving us this kind of nice relief, but also allowing more light to come in through this side. So this could be a kind of formal idea or a kind of practical idea with lighting. You will see the insulation line from the windows, which are inherently insulated, all the way up here, that they've created some additional protective insulation to keep a good thermal barrier from this outer space to this inner space. So we've got the steel, the decking, the insulation, the roof drain, the dropped ceiling. So this is kind of what those look like, a little indication. And they've actually given a kind of nice closure device here, which, I don't mind completely. But these are typically hung from the floor up above. It's pretty simple stuff. But we also start to see some miscellaneous steel. So steel that's out here on the exterior to help with our envelope systems. This is also a nice one. This one's made with concrete. And I think one of the things I like about this, we see the sloped insulation, we see the decking, we see the beams kind of integral as well as walls integral, and even sort of a little bit of a turn up on the roof to create, a kind of area on the roof for gathering water. But my favorite part of concrete details is always where they start to negotiate with steel details. So we see this hanging device that's kind of supported off of the edge of the concrete structural component, and that is the device that hangs the miscellaneous metals that helps us put up the various parts of the wall system. And you will notice here too, so we have this expression of glass, a glass wall with mullions, and we see the glass coming all the way up to the top here. And so we still have mullions up here, but imagine looking through at the edge of the concrete. That's not going to be very nice. And so typically our glass up at this portion of the wall is called spandrel glass. And it can be exactly the same glass as we had down below, but it has an opaque coating on the back, which allows it to basically limit view to the interior. But it will still have very much the same kind of feel as the glass of the wall. We have our hung ceiling, right, and our little hanging devices. We don't have a lot of the system showing in here, but I do like that we're starting to see kind of a differentiation of the ceiling as a sort of place of decision for design, right? We've got a kind of perimeter condition at the end, a kind of interior condition. Probably this is complemented with lighting on the interior. And then we have this sense of kind of the reveal at the edge where we see the ceiling not coming all the way to the wall, but sort of lifting up. This may be a condition that a lot of you may have, and there's a couple different ways to do this. Oftentimes we will talk about the steel frame not being right in the direct exterior line of the building, sometimes sitting kind of in an interior position relative to either the wall or some exterior space. So in a case like that, we've got the support for this steel condition down below on the foundation, but we also have kind of this idea of a little cantilever. So this is a nice detail to look at. We've got insulation sort of protecting that thermal bridging that wants to happen around the steel. But we also have this sort of really kind of great bracket that is holding up a tapered piece of steel that is basically holding this entire deck. So that's one way of doing it, is sort of cantilevering a piece of steel off of the frame devices themselves. Another way of creating this kind of exterior condition would be to, if we had our decking changed in the opposite direction and we had these little ridges that were running this way, we could actually cantilever that composite deck up to about 10 feet in order to carry areas outside of the envelope of the building. So this is another wall section that I found useful because it also shows quite a few other kinds of conditions that you may have in your design. So we can see, the typical components of the steel frame. And because this is our larger member and these are our smaller members, we will have these more regularly. We want to begin to build up a grid work of these secondary members at 8 to 10 foot spacing, because that is a really good spanning distance for this next system, right? So major member, secondary member, and then these little devices, the composite floor, spanning the other way. I really do like this though, because it shows quite a few things happening that are interesting. One of them is that our steel is always going to need insulation, fire protection. And so we have thermal insulation in part of this, but we also have almost a fire protection built in. In this particular project, there's a set of precast concrete covers that are really the expression of the building. So this is hidden inside of something else, which is doing the fire protection. I also like this image because we start to see some of the little details and where things like miscellaneous metals come in. So on the underside here, I have this idea of a kind of under canopy, but how do I get from this member here down to this canopy? And I think it's always a good idea to move backwards and forwards from the surface to the structure and from the structure out to the surface. So in this case, we've used a set of miscellaneous metals that are beginning to be supported here. We've got these kind of little stems and extensions of the steel work that are then helping to support a set of steel channels. And the steel channels, let's see if we can get a good label on this one. So there's a mineral wool insulation under here. There are some attachment brackets, and then there are these kind of panels that are suspended from these attachment brackets. So we have all of these little sort of nice devices that are helping to also support some of these metal panels. We have a little gutter that's worked in, right? That's a sort of terrific detail. And look at all this miscellaneous metal. To create this canopy, it's just full of little channels back behind that are all kind of built together in these frames that support either on the top a sloped panel, or on the bottom a kind of suspended panel. So inside is kind of a lot of material that never really gets shown very much. And so you may take a stab at that, or you may run in terror from that, but I really like it. This is another detail, and I thought this was useful because oftentimes we'll sort of wish that we could show the structure, but I think at this scale, really we do need to protect steel with fireproofing. But in this case, they used actually these precast elements. There's lots of fireproofing types, but in this case, they actually double dutied that the concrete cladding was going to be basically a fire protection for the frame. And so you do get the expression of a frame. It's not a wide flange, but we still get the kind of vertical columns and the horizontal members that are expressed through this covering. And the coverings could be concrete, the coverings could be metal, Even if you've got a diagrid, you will have some kind of either a self-insulating cover or insulation and a metal cover to basically isolate that from any kind of fire resistance. And I thought this one was interesting too. There's a rain leader. There's basically a channel for the rain to come down through the column, right? So where are we going to run those plumbing drains once they are on the roof? Where are they moving out to? In this case, they're moving out to the columns. And just to remind you where we're going is an axon of your focus area. We really want to see how those systems are integrated. How do the mechanical systems move through here? How do your bioclimatic systems work, and how are they detailed?